Students, welcome to the Magic Max video classes. Today we are going to see polynomials for class 9th. Already we are familiar with algebraic expressions. Algebraic expression is a statement of inequality or expression containing variables and constants. Example, as I have given here, 2x monomial, x square plus 3x 2 times 2x cube minus 3x square plus 4x plus 5. It has 4 times minus 3x cube plus 4x square minus 2x plus 1. Like that we can keep on telling many algebraic expressions. You note that all these expressions contain only one variable, only one English alphabet, that is x. And exponent of the variable are all whole numbers. In first example, 2x, no power means x to the power 1. Here 1. Here x square 2, 3x to the power 1. 2x cube power 3. Like that, exponent of the variable are whole numbers. Such expressions are known as polynomials. Polynomial is an algebraic expression in one variable, in which exponent of the variable should be a positive integer, that is a whole number. Here 2x to the power 3 minus 5x to the power minus 2 plus 3x to the power 1 plus root 5 is not a polynomial, since exponent of the variable x in second term is a negative integer. It should be a whole number. Whole number will be 0, 1, 2, 3, 4, 5, 6, like that. It cannot be negative. In second polynomial, you see x square plus 5 x to the power half minus 3 by 2x is not a polynomial, since in second term exponent of x is a fraction. 1 by 2 is a fraction. It is not a whole number. Some more examples for not polynomials. X to the power 1 by 3. 1 by 3 is a fraction. Root x means x to the power half. 2 into root x plus 3. 2x plus 1 by x. The x denominator, bring it to numerator, x to the power minus 1. Here all are not polynomials. Now let us see that what is radical form and exponential form. Root x means x to the power half. Cube root of x means x to the power 1 by 3. Nth root of x means x to the power 1 by n. Fourth root of x cube means x cube whole to the power 1 by 4. Then 3 into 1 by 4 is 3 by 4. A to the power m raised to the power n is a to the power m into n. Then 1 by x means x to the power minus 1. 2 by x square means x square, if we bring to the numerator, x to the power minus 2. A divided by x to the power n means a into x to the power minus n. Now what do you mean by constant polynomials? Any number is known as constant polynomial. Any number is known as constant polynomial. I have given some examples. The above constant polynomial, the exponent of the variable is 0. Therefore, degree of the constant polynomial is 0. That is very important. The degree of constant polynomial is 0. But the degree of 0 polynomial is not defined. Y means p of x plus 0 equal to 0 plus p of x equal to only p of x. Then any polynomial multiplied by 0, answer will be given 0, in which coefficient is 0, therefore it is not a degree of 0 polynomial is not defined. Now let us see types of polynomials. Linear polynomial in x. The standard form of linear polynomial in x is ax plus b, where a and b are real numbers and a is not equal to 0. Why it is called linear polynomial means the highest power of the variable x is 1. If the degree of the polynomial is 1, such a polynomial is known as linear polynomial. Why here a not equal to 0? If a is 0, 0 into x plus b will be b. It will be a constant polynomial. It won't be a linear polynomial. That is why a should not be 0. Now the standard form of quadratic polynomial in x is ax square plus bx plus c, where a, b, c are real numbers and a is not equal to 0. Here also the highest power of the variable x is 2. Therefore it is called quadratic polynomial. Quadratic polynomial is a polynomial in which highest power of the variable is 2. Here why a is not equal to 0? If a equal to 0, 0 into x square will become 0. It will become bx plus c. Therefore bx plus c is a linear polynomial. The cubic polynomial in x, its standard form is ax cube plus bx square plus cx plus d, where a, b, c, d are real numbers and a is not equal to 0. Now general form of polynomial of degree n in x. It is of the form p of x, polynomial of x, a0 plus a1 x to the power 1 plus a2 x to the power 2 plus a3 x cube and so on plus an x to the power n, where a0, a1, a2, a3 and so on an are real numbers, an not equal to 0. The highest power of the coefficients of the highest power of the variable should not be 0. And n is a whole number. That is most important. For polynomial, n must be a whole number. Also the real numbers a0, a1, a2, etc. an are also known as coefficients of the polynomial. Now let us identify the coefficients. Some example. Find the coefficient of x to the power 7, x to the power 6, x to the power 5, x to the power 4, x to the cube, x square, x and constant term of the polynomial 2 root 2 x to the power 7 minus 3 x to the power 6 plus 2 by 3 x power 5 plus 2x minus 7. Whichever term in this polynomial x power 4 is missing, x cube is missing, x square is missing. In such terms, 0 will be that any number plus 0, answer will not change. Therefore, coefficient of x power 7 is how many? X power 7, what is the number is there? 2 root 2. Coefficient of x power 6 is minus 3. X to the power 5, 2 by 3. As x power 4, x cube and x square terms are missing, therefore the coefficients are 0. Coefficient of x is 2. Then the term without x is minus 7. Now some important remarks. Degree of a polynomial is always a finite whole number. It will be a finite whole number. For a polynomial of degree n, there can be at most n plus 1. Degree n means maximum n plus 1 non-zero terms in the polynomial. Now special types of polynomials, that is monomials. A polynomials having only one term is known as monomial. That I have given an example, go through that. Polynomials having exactly two terms are called binomials. Some examples are given. Polynomials having exactly three terms are called trinomials. Only number of terms only you have to see. You no need to worry about the power of the variable. Now let us see which of the following expressions are polynomials in one variable and which are not. Give reasons for your answer. First one and second one are polynomials. Why they are called polynomials means in both expressions the exponent of the variable is a whole number. Therefore it is a polynomial. Third one, you see 2 root x can be written as 2 into x to the power of root 2 x power 1. 1 by 2 is not a whole number. Therefore it is not a polynomial. x square plus 3 by x square plus 4 can be written as the 1 by x square. The x square is in denominator, second term. You bring to the numerator x3 into x to the power minus 2 plus 4. Here minus 2 is not a whole number. Therefore, it is not a polynomial. Fifth one, it is a polynomial, of course. It is in 3 variables. But question is what? Polynomial in 1 variable. It is not a polynomial in 1 variable. Of course, it is a polynomial in multivariables. Of the leading terms in the following polynomials. Polynomials are given. First, we have to write the polynomial in standard form. Standard form means what is the meaning? We have to write the polynomial in descending powers of x, largest to smallest, if it is not given. Now here, highest power is x to the power 4, 10x to the power 4 plus 5x cube minus 7x square plus 5. The coefficient of x to the power 4 is 10. That is known as leading term. Leading term is 10. Second form, it is already in standard form. Coefficient of e to the power 6. The highest power is 6. The coefficient is 2. In third one, you can see that it is already in standard form. The highest power of variable t is 5. Therefore, the coefficient is 7. Therefore, coefficient of leading term is 7. Fourth one is not in standard form. Write in standard form. The highest power is t power 5. That is variable power is 5. Variable is t. Therefore, coefficient is minus 8. That is known as leading coefficient. Now, let us see the degree of each of the following polynomial. While finding degree of the polynomial, in which the highest power of the variable coefficient should not be, leading coefficient should not be 0. The definition, you see that the highest power of the variable is known as degree of the polynomial, but the leading coefficient should not be 0. Here the highest power is 5, therefore degree is 5. Here highest power is 8, degree is 8. In third one, the highest power is 11, therefore degree is 11. In fourth one, the highest power is 1, 6. There is no x at all, that is x to the power 0, degree is 0. Here 0 into x to the power, even though highest power of the x is 6, in which leading coefficient is 0, 0 into x to the power 6 will become, this term will become what? 0. That is why degree is not equal to 6. Next highest power is 4, in which coefficient is 3, therefore degree is 4. Degree is 4, not degree is 6. Next unit is zeros of polynomial. Let us consider the polynomial p of x equal to x square minus 4. If you substitute x equal to 2, then p bracket 2, p of 2 equal to polynomial function at x equal to 2 square. 2 square value is 4. 4 minus 4 equal to 0. If you substitute randomly, we can check that. If you substitute x equal to 1, then we are finding the value minus 3. If you substitute x equal to 0, we are getting minus 4. If you are substituting x equal to minus 1 whole square also minus into minus plus, answer will be minus 3. If you substitute x equal to minus 2, we get answer is 0. Now you see, I have put in tabular column, summarize the result. What are the values I have taken? 2, 1, 0, minus 1, minus 2. Corresponding values of the polynomial are 0, minus 3, minus 4, minus 3 and 0. Now in two places, it is 0 is coming. These are known as zeros of the polynomial. Zeros of the polynomial. The value of p of x is 0 when x equal to 2 and x equal to minus 2. Such values, for what value of x the given polynomial becomes 0, that is known as 0 of the polynomial. In this case, x equal to 2 and x equal to minus 2 are zeros of the polynomial x square minus 4. Now let us see some questions. Find the zeros of the following polynomials. What is the working rule means? First, let the given polynomial equal to 0. Then find the value of x from the given polynomial. The value of x is known as 0 of the polynomial. The polynomial is given as x plus 3. X plus 3 equal to 0. Then 3 bring to RHS. Therefore minus 3. Minus 3 is known as 0. Therefore 0 is minus 3. The 0 is minus 3. Then 2x minus 5 equal to 0. Then minus 5 bring to other side, plus 5. X equal to 5 by 2. The 0 is minus 5 by 2. Then ax plus b equal to 0. Then plus b bring to other side, minus b. X equal to minus b by a. That is known as 0. Similarly, 4th, 5th and 6th you can try. Now, today that's all the class. Thank you. You try to solve the questions from exercise 2.1.